All right, welcome everyone to our sixth and final lesson from our chapter or our unit on rational functions. Today we're going to be looking at how to solve rational equations. This is one of two videos. This video is going to describe how to solve these equations using what I call method one, or the preferred method in my case. This is looking at multiplying the equation by the LCD. There will be a second video uploaded just after this that you will also be able to see. And only one of them is required, but go ahead and I would suggest doing this particular method. So this method, first thing that you need to do is you need to determine the least common denominator for your entire equation. Once you have done so, you're going to multiply the entire equation, or both sides of the equation, by that LCD. What you'll want to do is distribute across all pieces of your equation. Once you distribute, you'll be able to simplify your entire equation so that there are no rational expressions remaining in the entire problem. Now the point of this is now that you've gotten rid of all of your fractions, you can now solve the remaining polynomial equation. Sometimes it's linear, sometimes it's quadratic. Very rarely you'll get a cubic, but for the most part we're going to be looking at linear and quadratic solving, stuff we've done plenty times before. Once you have then solved that equation, you need to check your answers. Sometimes you can get two answers where only one of them is the actual answer, and the second one is what we call extraneous, just basically meaning extra. But we have to cross that one out as that's not part of our final solution. So that's the how-to. Let's take a look at some examples. So we're going to first look at a relatively easy one, and that relatively easy one is going to look like this. 2 over the quantity 3x minus 5 equals 4 over x minus 15. Now the reason I want to start with this is because this one really doesn't follow either of the two methods. This really looks like one fraction equal to a second fraction. And we remember that our study of really Algebra 1, a little bit of geometry, says that if I have a fraction equal to a fraction, that's like a proportion, and therefore I can cross multiply. So in this particular case where you have a single fraction equal to a single fraction, you are allowed to cross multiply. So this 2 gets multiplied with the x minus 15. Then the 4 gets multiplied with the 3x minus 5. With a nice little equal sign between the two of them. And then this is a very simple solve. So we're going to distribute the 2, so we get 2x minus 30. We're going to distribute the 4, we get 12x minus 20. And then we get our x's on one side, and we're going to get the numbers on the other side. So here I get negative 30 plus 20 is negative 10, equals to 12 minus 2, which is 10x. Divide by 10, x equals negative 1. That was a very straightforward equation. It did not require method 1. It did not require what's going to end up being method 2. Just required some cross multiplication. This is a very, not rare, but this is a very simplistic rational equation. So let's take a look at something a little bit more complex that's going to require some multiplication. So we're going to look at 11 over 3x minus 1 over 3 equals negative 4 over x squared. So we need to look at the LCD. Something that we were looking at in the previous lesson is trying to find the least common denominator because we were trying to add and subtract fractions. So you'll notice that in this particular case, both of these have a 3, which means this one needs a 3. So a 3 has to be part of my LCD. This one has an x, but this one has an x squared. So I need to multiply to make these x squareds. And we can notice that our least common denominator is going to be 3x squared because I can multiply this equation by x if I wanted to, this equation by x squared, and this equation by 3, or expression by 3. Once we have the LCD, we're going to multiply the entire equation by that LCD. Once we do so, we're going to distribute onto all pieces of the equation. So we'll notice that we have our 11 over 3x. If you recall that this is 3x squared over 1, that means the 3x squared goes into the numerator. We have our 1/3 still, but we're going to multiply it by that 3x squared. And then we still have our -4 over x squared, but we're going to multiply it by 3x squared. If you remember, that last slide said once we distribute, we're going to simplify. Now, this is stuff we did also in one of our previous lessons where we simplified rational expressions. Both of those lessons were leading to this particular lesson. So here we're going to cancel our 3's. Those become 1's. This x cancels with this x, but it's left with an x to the first. So here in this fraction, I have 11 times x and just 1's in the denominator. So I get 11x minus. Here again, my 3's are going to cancel, and that's all I can cancel. So I'm left with 1 times x squared, which is x squared, equals, well, nothing, the 3's can't cancel, but both of my x squareds can cancel, and I'm left with -12. And now we have a simple polynomial equation with a quadratic here. So we're going to add x squared, and we're going to subtract 11x. Add x squared and subtract 11x. And we get this nice new equation that says 0 is equal to x squared minus 11x minus 12. And we know if we have a quadratic equal to 0, we're going to factor that quadratic. And we get x minus 12 and x plus 1. That means that x equals positive 12 and -1. Now, when you check your answer, you're really just having to check to see if either of these numbers make the denominator of the original equation equal to 0, and neither of these do, so therefore both of these answers are correct, and we get our answers. All right, let's try another one. Let's try a little bit more complicated one that has 4 pieces in our equation. So we get 5 over 2x minus 2 over 3 equals 1 over x plus 5 over 6. So we're going to come up here and we're going to say our LCD is, okay, I can change a 2 into a 6. I can change a 3 into a 6. That means our 6 is part of our LCD. And all I have is just x to the first power, which means I can get an x on all of them. So we're going to multiply everything by 6x, which is our LCD. Now, I'm going to show you in this particular example what we'll wait to the next example and show how I usually do this problem. So here we're going to get 5 times 6x over 2x. We're going to get 2 times 6x over 3 equals 1 times 6x over x plus 5 times 6x over 6. We're going to go through and we're going to do any canceling that is available. We're going to cancel our 6's, those become 1's. Cancel our x's, those become 1's. We're going to cancel that 3 on the 6, but that becomes a 2 in the numerator. Same idea here. We're going to cancel the 2's. That becomes a 3. And we're going to cancel those x's. Those become 1's. So now everything across the denominators are 1's. We get 5 times 3 times 1, which is 15. Minus 2 times 2x, which is 4x. Here this is just 1 times 6, which is remaining. And 5 times x, which is a 5 times x, which is just 5x. And then we're going to do the simplistic linear equation here. Add 4x. Add 4x. And minus 6 minus 6. So therefore I get 15 minus 6 is 9. And 5 plus 4 is 9x. We're going to divide by 9. Therefore x is 1 and done. All right, same exact idea. This time it just had 4 parts to the equation and not much left from that. So now we need to look at ones that we might have to factor as we go forward. So let's take a look at 5 over x squared minus 7x plus 12 minus 2 over 3 minus x equals 5 over x minus 4. Now, there's something in this particular problem that I would like to point out. One of the previous videos said something about the 3 minus x. 3 minus x is just the opposite of x minus 3. So a good thing to do in this case is to change that, because we like to look at 3 minus x as x minus 3. So we're going to do that in the next step, but I need to factor this quadratic because I need to know the common denominator. So here we're going to go x squared minus 7x plus 12 becomes x minus 4 and x minus 3. Now, notice this is a minus sign, but I want the opposite of x minus 3, so I'm going to change this to a plus, and I'm going to change this to x minus 3. And now I get a nice simple equation. I look at this and I look at the denominator here is x minus 4, x minus 3, and I have x minus 3 and x minus 4. That means our LCD is x minus 3 times x minus 4. So that's what we need to multiply the equation by. Now what I'm going to show you, like I mentioned, is I'm going to show you how I normally do this. I don't normally write the multiplication out. I do write this particular piece that I'm doing here. And with the arrows, I like to cancel as I'm multiplying. So when I take this big first arc, if I was to multiply this first fraction by x minus 3 and x minus 4, both of those are going to cancel out of the denominator, and they're going to cancel these guys. So I'm just left with 5. Here, if I was to take both of these factors and multiply by the 2 over x minus 3, the x minus 3 is going to cancel with this x minus 3. So I'm left with 2 times x minus 4. And likewise, with the last fraction, if I multiplied both of these factors, the x minus 4 is going to cancel, and I'm going to get the 5 times x minus 3. Now, the reason that's, to me, nicer is that it eliminates a single step and eliminates some of the other canceling that needs to happen. So now I can go and do the simple algebra here. I can say 5 plus 2x minus 8 is equal to 5x minus 15. And then I'm gonna simplify this over here. I'm gonna say this is 2x minus 3 because 5 minus 8 is negative 3. I'm gonna say this is 5x minus 15, and we're going to finish this up by subtracting 2x. And we're going to add 15 to get to the 15 on the other side. And negative 3 plus 15 is 12. This is equal to 3x. And we divide by 3, and therefore x is 4. But here is a problem. If we were to take 4 and plug it back into this part of the equation, or even the beginning part of the equation, I would get 0 in the denominator, which means that is extraneous. And since that was the only answer that we got, that means that there are no solutions. There is no solution to this particular equation. And that's okay. What you've done is you've proved that there was no solution to that particular equation. All right. So that doesn't mean all equations, don't get this wrong. There doesn't mean all equations don't have solutions. Most of our equations should have some sort of solution, at least one or two answers. All right. Once again, I'm going to erase this, and we're going to go on to this. I'm going to leave you with this. If you're interested, I'm going to post a second video shortly after this one is there for your viewing. All right, I will see you guys later.